the grade, and I noticed that a lot of people aren't doing so well. Of course, they're probably the people who aren't here. So, like, everybody.
I have my computer, and we try to ask you after class Tuesday to open the quizzes so that I can take them.
Oh, okay.
I'm trying to figure out
It says to email me about those things anyway, because I forget if I don't have the email, but if I have the email, I can do it right there before I mark my email as read. So, yes.
It's not writing down back, but I put all the online stuff. I haven't done paper because I see where the question says do. I have the ebook. Where do I go ebook that time?
So ebook direct link, you would click on that, and then there are contents, and you click on the contents, and there's a drop-down menu, and you can open up part 1, which each of these chapters 1 through 4, and then you can open up chapter 1, and then you can jump to the exercises at the back, chapter exercises or something like that is what it's called. So, all under contents, and you can see those there. Scroll through the pages with the arrow.
But there's no, arrow, but is there any quick way to go through it?
The content, yeah, the content. There's a tab at the top that says content, and it drops down and you do part 1, and it drops down and you do chapter 1, and it drops down and you do the chapter exercise. Yeah, so many. Expanding. We're going to go ahead with chapter 4, and so we'll cover chapter 4 today. On Tuesday, we will talk about chapter 5 and do an activity. On Thursday, we will do an activity and review for the exam. So this is all about gathering data. So we've talked about an introduction to what statistics is. We've talked about how to represent data, both as pictures and as single values in chapter 2. We talked about the association between data with two variable data. And then in this section, we're going to actually talk about how to gather data, which is extremely relevant to Project 1. You have hopefully already gathered all of your data and have started the other part of Project 1 because there's a lot of analysis to Project 1 as well. And it was originally due Sunday, but now it's due by Tuesday at midnight. But you should still complete your part by Sunday night or Monday night at the very latest, because you have to post it 24 hours in advance, your part of the project 24 hours in advance of the due date, so that everybody can review everybody else's part and look at the rubric and go through the rubric and make sure that every single part is done as it should be. So be sure to get that done by Monday at the latest and posted for your group to see. And preferably posted on D2L so that I know that you've met that deadline, and post your reactions to other people's once you get that final draft put together, reactions to other people's input, and that, so I know that you have graded them with the rubric. Was there a question? Okay.
You said the directions, you could talk to each other in the virtual room. Like, I can not really that, but like, how can you?
I really want the group discussion, so if you go under discussions inside the class and scroll down, there are group discussions, or maybe I should move that closer to the top, but it should, if another group member has posted, it should say you have so many discussion messages unread, and you can jump right to those. But.
And he's still not added to my group. He's saying only have 4 members.
Okay. Email me, and I will check on that and make sure, and tell me which group, because I think that you're in a group, you're probably just in the wrong group. Because I think that you are in a group, but you are probably in the wrong group. Because I think that everybody but one person, and I can't remember who that person was, but I'm pretty sure it's not you, Robert, was in a group at one point. Oh, I do now remember who that person was, and they're in a different section. Huh? Yeah, right. Yeah, who's enrolled in the class.
Does that group have like one name?
No, you could call yourself Group 5 or whatever, if you want that. And so, Chapter 4, gathering data, a lot of this, the Part A has a whole bunch of questions, and they are from this chapter, so if you're assigned Part A, you definitely want to pay attention to the stuff in this chapter. We start off with, should we experiment or observe, because that's really the two types of ways that we gather data. And then we talk about, go into more detail on how we observe through sampling, go into more detail on how we experiment, and then we talk sort of a hodgepodge section of other ways to experiment and observe. So to experiment or to observe, we'll talk about population and sample. We've already mentioned it a little bit, and we'll talk about it here too. We'll talk about experimental and observational studies. Those are the two types of studies, the two ways that you go about gathering data. We compare experimental and observational studies. So here is population, a representation of the population. The population is everybody that you're concerned about, everybody that you're going to make conclusions about. So for those of you who are surveying and you're asking about Fort Campbell area residents, that's going to be your population, the adult Fort Campbell area residents. Some people only surveyed parents of girls, so they asked about Girl Scouts, so your population there would be Clarksville area parents with girls. So then your sample is going to be a smaller set than your subset, and it's going to hopefully well represent your overall population, because you're going to use the data you collect on the sample to make conclusions about the population. And we'll be using statistical techniques in Part 1, but also in Part 2 and Part 3, we'll learn more and more and more statistical techniques that we can use to take our sample and apply to the overall population. So an observational study is sort of a hands-off, unobtrusive study. Even what y'all did surveying, it only asked questions. It didn't require that the participants do anything. So it's very hands-off. Sometimes people don't even know that they're being studied, that they're being observed. So people could do a study on how many Math 1530 students passed the course. And so that would come from data that's already collected on you. You may not even be aware of that data. Yes, Cody? We're going to talk about that in the last section. So the double blinding is a very important concept, and that's in the very 4.4. So we will get there. Other questions? That deals more with experiments than with observational studies. So an observational study is really what you did by using a sample survey. And a sample survey is a great tool for an observational study. As a matter of fact, I would say most observational studies are probably done through sample surveys. You select a sample that hopefully represents your population, and you interview them and ask them questions. And a census is also a survey, but it is not a sample survey, it's a survey of the entire population. So if you are able to do a census, which is rare if you're doing the entire United States, but it does happen every 20 years, but if you need more specific data than that on the entire United States, you're not usually going to do a census. If your population is small, however, like if it were this classroom and we assume that people actually came, because there should be more people here, there should be 21, well 22, including Katrina, 23 if you include me. Everybody did. We could do a census on a small population pretty easily, so that does happen sometimes if you've got a really small population. And experiment, on the other hand, is quite different from just observing, because you're actually imposing something on your participants. So, especially if you're experimenting on human subjects, that becomes a very sensitive sort of issue. And experimenting on underage human subjects is probably almost always forbidden. It depends on the circumstances, but you want usually adults, and you want them to volunteer, and you want to have very professional researchers if you're ever going to do these sorts of experiments, because you're actually doing stuff to your patients. Medical experiments, drug experiments, those are the most common experiments. And you'll have experimental conditions that are set up so that it's a very controlled environment. So that's what makes it different from just observing, because you're just observing what's already happened. With an experiment, you're controlling what has happened. And so you'll set up these treatments, and the only thing that's going to be different in each of the different treatments, each of the different treatment groups, is the treatment itself. So you're removing sort of all of the lurking and confounding variables, and you're in control of all of that in an experiment. The treatments are from the explanatory variable. So you have the variable that you think will explain, like the drug. You think your drug will explain relief in pain, for example. And so you will do different levels of your drug, and that will be your different treatments. So different values of your explanatory variable will be the treatment. Not exactly the same thing, explanatory variable equals treatment, but values of the explanatory variable will be the treatment. And so why do we use experiments sometimes? Why do we use observational studies sometimes? What are the advantages and disadvantages? We use experiments because, remember, in Section 3 we talked about association does not imply causation, does not prove causation. The only way we can prove cause, actually, is through experiments. Because we are controlling everything, because the only difference between the different treatment groups is the treatment themselves, then we know that what we've shown doesn't have lurking variables, doesn't have unknown confounding variables. So we know that if there is a difference in the outcome, it's due to either randomness or the treatment itself. And if you do enough replication, you can outrule randomness. That if something happens so often, it's not going to be random if something's repeated so often. So experiments are sort of the only way that we can actually prove that stuff is true. With that in mind, it would seem like we want to do experiments all of the time, but there are disadvantages to experiments. Number one, sometimes you can't even do them logistically, and we'll talk about one example where it's logistically impossible to actually do an experiment. But then you've also got ethics. Again, when you're doing stuff too, especially human subjects, you've got to be extremely concerned about your ethics in doing something that could cause harm. You've also got to be concerned about time and money, because these are certainly more expensive than just asking questions about what people have already done. Here are some examples. Helping low-income smokers quit. We have a study with 233 low-income smokers wishing to quit. They had some doing the usual care, and the usual care was meeting with the doctor and then following up with that doctor. And then some of them had the usual care plus this computer-assisted counseling service where they would call up and counsel them and make sure that they were motivated to stay quit and that sort of thing. And then after 3 months, the percentage who had quit smoking was higher for the group who received counseling. So they had both of them receiving two doctor's visits, and then one group also receiving counseling, and the percentage who would quit with the counseling was higher. What was the response variable, do you think? That was more of an explanatory variable, the counseling itself, because that would hopefully explain this. I've got my head. Oh, okay. Renee, so the counseling is an explanatory variable. There's also the usual care, right? Both of them, I guess, received usual care. One received counseling and one didn't. So it would definitely be more with counseling. And then, what would be the response? What would they look for in response to? Yeah, the smoking status. So whether they quit or not. Was the study an observational study or an experiment? Yeah, it's an experiment. Why?
Because they actually used on the subjects, like they were human subjects.
Yeah, but you could do that with observational studies too. You could have professionals interview human subjects. Yeah, they did something to the subjects. They required that they had the counseling, and they told them whether or not they were going to have the counseling. So it's not something that the subjects could have chosen themselves. There wasn't a voluntary choice to choose the counseling or to not choose the counseling. They volunteered for the study, and so they were told what they had to do, whether it was counseling or no counseling. And how does the design take into account potential lurking variables? Yeah, but I guess they could still cheat here too. A lurking variable is a variable that's not measured, that you don't consider. Like we looked at the examples in the last section of ice cream and drowning were associated, but the lurking variable was temperature. So anything that's hidden that you didn't take into account.
I would say a lurking variable is to possibly be something that your person has multiple areas.
Yeah, because if you're doing an observational study, it may have been a long time since that person tried to quit.
Like their age too.
Yeah.
That could be about how long they did.
Their activity level.
Yeah.
Yeah.
Or drinking, like when people go to the bar, they drink.
Yeah.
Or they smoke.
But I guess that's really controlled here. But what is controlled is that they told them to receive the counseling service. So if you were just doing a normal observational study trying to replicate this, you would probably go out and ask people, did you receive counseling, did you not? And then you would look at those who did and you would look at those who didn't. But the ones who did and who did on their own receive counseling are perhaps the ones who are more proactive, more serious about quitting, willing to pay for the counseling, willing to take the time for the counseling. And so that puts them in sort of a different bracket than those who didn't go through the extra effort to get the counseling. So it removes the choice, and so it sort of levels the playing field. I mean, there's other stuff that can go on, but it's equally likely to happen to the counseling group as to happen to the group who didn't have counseling.
So you're talking like the non-compliant people that fail to think that have to do counseling.
Well, I think all of them that had counseling assigned actually went through with the counseling. But what I'm talking about is if you didn't do an experiment, then nobody would be assigned counseling. They would only seek it if they really wanted it. And if they really want the counseling, they probably want to quit more than if they didn't want the counseling, didn't seek it out. Does that make sense? Okay. Explain whether these would be better as experiments or observational studies, whether or not smoking has an effect on coronary heart disease. You wouldn't want to assign people to smoke and assign people not to smoke to see if they get a heart attack. Whether or not SAT scores tend to be positively associated with higher college GPA. Yeah. Why observed here?
Because you don't know, like, subject, like, sensitive subjects, based on if they're assigned to study more or go to, like, SAT type class.
Yeah. I don't think it's logistically possible to assign someone an SAT score. They get what they get. You can't tell them, I mean, I wish you could, you can't tell them to get a 1600 and then they go and get a 1600. So,
Different things to help them get.
you could help them, yeah. But that would still sort of be observational because you're not actually assigning them an SAT score. Or maybe it would be an experiment that it would be the tutoring versus not tutoring instead of SAT scores that you would be comparing. Okay, see whether or not a special coupon attached to the outside of the catalog makes recipients more likely to order a mail order from the mail order company. Yeah, that can be very easily done as an experiment because you just, whatever the catalog is, it's already being decimated to whomever is being disseminated, and you just add the coupon at random, and that can be completely.
It could be observational because you're waiting to see how a coupon is being.
An element of it is observational, and really all experiments have an element of observing. So you do something too, and then you watch what happens. Any other comments or questions? Physician likes cold turkey, so a physician who's practiced for more than 20 years believes that going cold turkey is more effective than nicotine patches and other smoking cessation methods in helping smokers quit. The physician gives as evidence his observations of patients in practice. We want to explain the limitations of this evidence, and it's called anecdotal evidence, and what that means, the book defines it. It's sort of where you look at only what you see, so you don't seek out, you don't survey people, you don't do experiments, you just look at the people around you, see what's happening to them, and make conclusions. So if I knew several people who had taken this particular drug and had success with it in relieving disease or certain things like that, then that would be anecdotal evidence. Yes, Cody? Yeah, it's certainly not an experiment, but even an observational study, I think, would be better than by or the evidence that he has, than the evidence that he has. So because there's no control group, this definitely is not an experiment. Other comments?
I would say I think it would be proven because there's no evidence to be like long home.
Well, he's seeing patients, and probably the patients he's seeing have, my guess is that all of them have gone cold turkey since that's the method he prefers. But my guess is also that he hasn't seen many people quit with patch, at least not under him, because he doesn't believe in the patch. Right. So if he has seen people with patch, it's probably because they went to other doctors or tried the patch on their own, and the only reason they would tell him that is if the patch had failed. And so he's probably only going to hear the failure story. Yeah, it's very biased. And the reason it's biased is because it's using anecdotal sort of evidence, which is often biased because it only gives a very limited view, what we see, but what we see does not represent everything. And then alerting variables, again, could be that the reason they're bringing up the patch is because it hasn't worked for them, or probably If he's somebody who always pushes cold turkey, they probably wouldn't bring that. Right. If he's a bias already towards the cold turkey method, he might say, well, you can try the patch, but I doubt it will work. That sort of thing. 4.2, so in here we're going to go into more details about sampling particularly, and so what are good and poor ways to sample. We'll talk about the sampling frame and sampling design. We'll define what a simple random sample is. We will use the random number table. We will calculate the margin of error. We will talk about convenient samples, the types of bias in a sample, in sample surveys, and the key part of good sample surveys. So a sampling frame is sort of like a list of your entire population, or at least that's what you want it to be, because if you have a list of your entire population and you're drawing at random from that entire population, you're getting a really, really good sample. So you hope that you have in your sampling frame really a list of every single member of your population. And then sampling design determines how you select your sample from the sampling frame. Random sampling is the best way, and there are actually 3 types of random sampling, but we only talk about the first type here. In the very last section, 4.4, we'll talk about the other 2 types. But every sample you want to select randomly, because if you don't, if you just select from your friends, we run into the same problem that doctor saw, of anecdotal evidence. So our friends around us are like us, and they are like each other oftentimes. So you only get a very limited view if you only do your friends per se. Or really anything that's not random. You're only getting a very small, limited view, and it won't represent the overall population. So you definitely want to sample in some random way. The randomness way of all, shouldn't have tried that today, is the simple random sample. It's just really completely at random. You need the entire sampling frame to be the entire population to do this. And you just can maybe number everyone from 1 to 1,000 and then choose random numbers using a random number generator in our calculator, or we'll show you using a random number table. Or if it were a small population, write everybody's name on a piece of paper and put it in a hat. That's the same sort of philosophy that goes into random number generators, though, just on a larger scale. So here is how we would generate random numbers. Let's suppose that we had an assembly line making pencils, and we wanted to make sure the pencils were good, and we wanted to test 10 pencils a day, and 500 pencils were made. So we would number our pencils 1 to 500 as they came off the assembly line, and in order to decide which 10 we wanted to test, we would want to choose them completely at random. So we would number our subjects 1 to 500, then we would select numbers that were at random that in this range. So we might start with row 4 of this random number table, some row, and here we want 3-digit numbers, and it really should be, I guess, 001 to 500. So 001, if we got it, that would represent the first pencil. If we got 500, that would represent the last pencil. If we got 242, that would be the 242nd pencil that came off the assembly line. So we need 3-digit chunks. So 421 would be our first pencil that we would choose, 421. And then we get 679, but that's not in our range, right? The 679th pencil. And you might be tempted to just subtract 500 or something, but it's not a good idea to do that because that might make certain numbers more likely. Here, with it being 500, probably not, but if it were 400 or 200 or something like that, it would. So just throw out any numbers that aren't in the range. And then the next one's 309. and then oddly enough, something really close is the next, 306, and then 243. And then we would throw out 616 and 800 and 785 and 616, and then we would get 376. And I'm not going to keep on going, but that's how you would do it. If you had gotten 309 and 309, which we almost did, we would have skipped the second 309 because you wouldn't sample the sample spot. Any questions about how this works?
You always spend the fourth one.
No, but the course compass or the book will tell you which one to start with.
Does it always have to be numbers, or like?
No, it depends on what you're surveying. So if we were surveying 1 to 25, we would use 2-digit numbers. Or 1 to 1,000, we would use 4 digits. Other questions?
And
It'll tell you where to start, what line to start, and what numbers you're looking for between what and what. And here we have a margin of error. So when we do our survey, we might ask, are you military? And yes or no. So if we have 72% say they are military, and if you surveyed on base in that, or if you are associated with the military, then you might be something like that. So 72%, and we surveyed 36 people, it turns out that's going to have a margin of error. And the margin of error is how much error is possible in that number. If you were really random, assuming you were really random, and how much error you would probably have using your sample to estimate the whole population of people that were running around on tests. So you would plug in your n, let's say 36, and 1 divided by 36 times 100, 1 divided by the square root of 36, sorry. I think that's going to be 16.7%. Is that correct?
Yeah.
Okay.
16.6.
Yeah. Yeah. So I chose the perfect square so I could do that. I totally couldn't have done the square root of it. Yes.
How come, just for a moment, margin of error, I see, Mike Gallup poll, and they say their margin of error is 3%.
Yeah, that's an excellent point.
They sample thousands.
Right. If we did 1,600 people, what would be our margin of error? 1 over the square root of 1,600 times 100. 2.5. So 1,600 is 2.5%.
So the more you serve, the smaller it is.
Yes.
You would think it would be a margin because more people serve more.
Well, do you want error to be large?
No, because you have you have a larger sample of population, that's why your margin of error is.
Yes. So you want small error, so the more people you survey, the more precise your answer is, the smaller your error is. So if you survey a whole bunch of people, you want it to be small error. Here, our 72%, if we did plus or minus, we'll go ahead and round it, so it's easy to calculate. So plus or minus 17%, then that gets us a huge range. So what, 65? No, 55, right? 55 to almost 90, 89, 55 to 89. So that's horrible. Yeah, I mean, it's not horrible, but say between 55 and 89% of people on base military or family and military. I mean, that's not very precise at all. So if you had surveyed 1,600 people, on the other hand, or, you know, even 1,500 or 1,400, you could do the 3%. And so then you could say 69 to 75%. And that's much more precise and much better guess. Any comments, questions? The reason there is the sort of opposite relationship between sample size and error is because sample size is in the denominator. So that gives you an indirectly proportional relationship. But even intuitively, we would expect that because error is something we want to reduce. We can reduce error by increasing the size of our sample. We increase precision too. And that's as we would expect it to be. Again, like you said, most Gallup polls, political polls will say plus or minus 3 percentage points. That's where that's coming from, the margin of error. And that was the British Prime Minister election that happened a year and a half ago, maybe. So convenience samples are actually poor ways to sample. They are convenient, so tempting, but they're actually poor ways to sample. And one of the most convenient, overused, poor ways to sample is the internet, because it is so convenient to just pop up a survey. But really, your answers to that survey are restricted to only the people who visit your website. So if you put up a survey about do you approve of handgun licenses, you know, on the NRA site, you're going to get very different responses than if you put it up on the ACLU site. And so it's really restricted to the types of people who visit your site, and even then, it has a huge amount of non-response size that we'll talk about in the last section. So if you're doing web surveys, they really are restricted to the audience that you're hosting on the website, and even then, they're not as good as you could get by doing a face-to-face survey. And the same kind of goes for email. People might be a little bit more likely to respond to email surveys, especially if they're from people they know. But again, if you're sending to people you know, that's not random. So lots of problems with convenience samples. They could not be, yes, Cody?
I heard a lot of controversy about the policy. I heard a lot of controversy about how, like, polls surveys for citizens in because people, they were called landmines. Landmines, when people
Yeah. Yeah. So door-to-door is probably your best option. That's another type of convenience sampling. There are a lot of other types of convenience sampling. What we did, actually, what I encouraged y'all to do, was really a convenience sample. Go where your population is very likely to frequent, but if you're going to the TX or you're going to the gas station, you're going to get the types of people, you're going to more likely get the types of people who frequent those, who go to the grocery store every day, who go to the gas station often, who drive a lot, that sort of thing. So what we did was a convenience sample, but it's not as bad, it's not as flawed, as biased as an internet sample, because it's not maybe quite as convenient. Usually the more convenient, the more biased it is. Not always, but oftentimes. But it's important to consider this. Really the only unbiased way would be a door-to-door, and that's more than I wanted to require of people. Again, it's sort of invasive when people, I think, come to your house and have questions, and then also it takes a lot more time and effort and energy to go do it.
After orders, who was actually posting telling people
Yeah.
they're asking how you get to work, how you do
What we do. A volunteer sample is another way to do a convenience sample. It's the most common way to do a convenience sample, so you get people to volunteer to participate in your survey. And in a way, you can't really survey people without their permission. I mean, you know, I would not recommend holding them at gunpoint, for instance, and having them complete your survey. But there are ways that you can approach people that will make them more likely to respond and be willing to participate, like we talked about the gas stations. And so they're captive anyway, so they might as well answer 5 quick questions. Bias. So here are 3 types of bias, and you'll see these again and again in your homework and the quiz, and so it's good to familiarize yourself with the 3 primary types of bias. And when it asks for the type of bias or bias that happens, it's usually asking for one of these 3. Sampling bias is the way you chose to do your sample. And I think in your project report, you'll have to address, did my project, what sampling bias did it have? And I will go ahead and tell you that probably all of you have some sampling bias. And you'll just list it there and try to explain how maybe you mitigated it to the extent possible, but there was probably some sampling bias. And some that wasn't completely, purely, purposely random. And then non-response bias happens when you have more than a few people say, no, I don't want to take your survey. So if you had 1 or 2, I guess that would be mild non-response bias, but I wouldn't consider that a problem. But if half of the people you approach said no thank you, then that does have some non-response bias. The internet surveys, I would say less than 1% actually do respond. So you've got tremendous non-response bias on internet sorts of surveys, email sorts of surveys, even mailing sorts of surveys. When you mail it out, probably more than 1% respond, but not usually more than 10 or 20% respond to a survey being mailed to them in the snail mail. And then face-to-face surveys have the least amount, I would say, of non-response. Usually, if you're going to ask somebody face-to-face to participate in a quick survey, they'll agree. But phone surveys, even if they do have landline phones, I look at the number, and if I don't know the person, I don't usually answer, or if it's not a local number, so sometimes I'll answer if it's a local number. But if it's not local and it's not somebody I know, I won't answer. And then even, if I do answer and if it, sounds like a salesman survey. And then you've got response bias. And there are some sensitive questions that you might ask people, and especially if you are asking them and they're looking at you, they're not going to really want to tell you the truth. Or if they're listening to you and you're listening to them, so sometimes one group asks, do you text and email, or do you text while you're driving? And I thought, ooh, I wonder if anybody will tell the truth on that. And they actually did, because they gave it to them and had them give it back and not write their name on it or anything, and just, sort of gathered them around. They actually did get like 70 or 80% say yes, they had texted while driving before. So I thought that was, it definitely is against the law. No, it's against the law in all of Tennessee.
It is. I am guilty of texting and driving, but they say that if you're at stops or whatever, then it's not, because you're not moving. If you're at a stoplight or, obviously not a stop, I do it go long enough, but.
I sit at the school for hours, and I'm like, I'm living out the phone waiting for them to start moving. Yeah. I'm sorry, what type of survey was it? And you did it at no, it wouldn't be a bias if you listed your population as comic book fans. But if you listed your population as the general U.S. Or Clarksville area resident population, then it would be a bias, because if you ask a question like, are you a fan of comic books, then obviously you're gonna get an astronomical. Yeah, well, duh. So, you've got to name your population right. Yeah. Other comments, questions? Key parts of a sample survey, so you want to make sure that you have these. You want to identify your entire population, and you want to identify it accurately. Like if you did go to the comic book store, you're looking at comic book fans, those interested in comic books. You want to construct a sampling frame, and ideally you want to be able to list out the members of your entire population. That probably wasn't possible for almost all of you, maybe all of you. But in an ideal situation, to do a simple random sample, that's what you would be able to do. And then you want to use a random sampling design to get N subjects from your sampling frame. And N is your sample size here, by the way. And we will use N to represent the sample size most of the time. Or all of the time, whenever, but I mean, that's really what N means, sample size. So to get our sample size, we'll use some random sampling design. We've talked about simple random samples, but there are two more. And we want to avoid sampling bias. Actually, we want to avoid all of the different types of bias, the sampling, non-response, and response, to as much as we can. So in example 4 in the text, it talks about selecting club officers for a New Orleans trip. 2 of the officers selected in that example to attend a trip, but in this example, we want to select 3 officers to get fully paid trips to New Orleans. And these are the different officers, president, vice president, secretary, treasurer, and activity coordinator, I think. So if we select 3 at random, what might a set of 3 be? SPA, CBT. What I like to do is to try to list them in an order from left to right, well, as they're listed up here, and try to list as many to the left as I can until I've exhausted all of those possibilities. And by having a sort of method to it, I found that I'm less likely to skip stuff, because we've got to list all of them. So from left to right, PBS would certainly be the first set. And then I could also do PBT, right? So left to right again, PBT. And then there are more PBs, right? Yeah, we're still trying to do as many left to right as we can to try to exhaust all the PBs. And have we exhausted them all? Mm-hmm. Now we can start with PSs, right? So PST and then PSA and then PTA. Yeah, that's in SHUSAR, but we don't actually talk about that in this course. Some statistics courses do cover combinations and permutations, but we don't cover that in here. And then if we go, starting with the V, so we would have VST, and then VSA, and then VTA, and then STA. And that's it, right? As long as you don't say SAT, because that's the same thing as STA. That's the same for the people. You know? So, are there any questions about doing that? And then, what is the chance that a particular sample will be drawn? 1 out of 10. Because there are 10 samples, and each of them would be equally likely. And then, what is the chance that the activity coordinator would be chosen? Yeah, 6 out of 10 would equal 60%. Well, but I was thinking simplified fraction form. Close.
Three.
So how did y'all get 6 out of 10? Yeah, so 6 of these 10 have A's in them. What's another way that you could have determined that the probability of an activity coordinator going is going to be? Well, they're selecting 3 of 5 officers, right?
Oh.
Yes, that's 3 of 5 for the activity coordinator. No, that's fine. There are multiple ways to do these problems. That's the most, because we've just done it, that's the most easily observed, I guess. Here we have a random number table, and it tells us that we want to start with the second row of digits, and a class has 50 students. So, yeah, we'll do 2 digits from 01 to 50, and our first will be 22, and then 36, and then, well, not 84, right? Yeah, not 65, and not 73. 25.
Now, why did we skip?
Okay, so we skip 84, 65, and 73 because they're more than 50.
Oh, okay.
And yeah, 30. Yeah, I won't keep going on if that's okay. If we had repeated any, we'd skip those too. Are there any questions about how to do this? Whoops. Local telephone directory has 50,000 names, 100 per page for 500 pages. Explain how you found and used random numbers. Select 10 numbers to identify the subject for a simple random sample of 10 names. With this, I would actually select 10 random numbers for the pages and then 10 random numbers for the person on the page. So I would select 10 random numbers between 1 and 500 to determine the page, and then to determine the person on the page, I would select 10 more random numbers between 1 and 100. And then you could use the random number table to do that. You could also use your calculator to do random numbers. So your calculator function is math PRB psi. So you click on the math key and then select PRB and then select option 5, and it does rand-in. And you could tell it here, I want 10 numbers between 1 and 500. So I would say 1, 500, 10. And then for these numbers, I would say rand-in 1, 100, 10.
Oh, wow.
Well, I think it has a common key in the calculator. There's randomimages.org that actually has probably a time feed because it does much more randomly than the calculator. And then there's some awesome random number generators that use quantum physics to actually generate something that's purely, completely, 100% really random. No, it's a program, has the same seed in every calculator. So it's random in that if you've done the 27th time, it's different from the 28th time, but it's not random in that if you open up 2 new calculators, they'll give you the same set. So then you would use those to say my page number and my person number on that page.
So my question is, if we get a question, will we use that program in the calculator? Will it be the same as it is in?
Course templates will more likely ask you to use a random number table so that it will be. I used to do, but I'm not sure I still do. I don't think I do still do, a question on what's the process of doing your own calculator. But I don't think I do that anymore now that I'm using all. But it's just nice to know that you have that option there. I consider the random number table sort of an arcane before technology way of doing random numbers. There are other ways to do it. Margin of error, the Gallup poll in example 6 reported that 56% of Americans believe New Orleans will never completely recover from Hurricane Katrina. We want to find the margin of error, and it's 100. So what's the formula? 1 divided by? And that would give me and then part D says 400, and that gives me, and then C says 1,600, and I think we already did, yeah, and that gave us, Are there any questions? And we did talk about how the margin of error increases margin of error decreases and sample size increase. A political scientist at the University of Chicago studied the effects of race of the interviewer. Following a phone interview, respondents were asked whether they thought the interviewer was black or white. All were actually black. Receiving a white interviewer resulted in more conservative opinions. For example, 14% agreed that American society is fair to everyone when they thought the interviewer was black, but 31% agreed to the statement when posed by an interviewer that the respondents thought was white. Which type of bias does this illustrate? Sampling bias, non-response bias, or response bias? Response bias. And again, that's because the response, people are tempted to lie, even if they don't realize that they're tempted to lie, or tempted to give a different answer depending on the interviewer. They are, in fact, and that's what this study shows, that the way you ask the question, the person asking the question, the perceptions of the person being interviewed affects the answers to questions. So be aware of response bias. And Confederates. So some southern states in the U.S. have struggled with the issue of the state flag being sensitive to, that is sensitive to African Americans and not divisive. Suppose a survey asks, do you oppose the present state flag that contains the Confederate symbol, a symbol of past slavery in the South, and a flag supported by extremist groups? So explain why this example is a leading question.
Because you answer it, you support it, really want students and marketplace itself.
Yeah, the answer has already said it's supported by extremist groups. So that implies if you answered yes, then you must agree with extremist groups. So I explain a better way to ask the question. So is this a better way to ask the question, do you favor or oppose the printing state flags containing the Confederate symbol? Okay, it lets them know it contains the Confederate symbol, but it doesn't make any judgment on that symbol. So one group, I think it was in the other class, had asked how often do you change your toothbrush sort of question, but they'd also said that dentists recommend changing it every 3 months. And I told them that they would want to leave that part out of the actual survey itself so that there's no expectation in their answer. They'll get more honest answers that way. It may not still get completely honest answers, but they certainly would get a lot of answers that were 3 months if they said that, I think. All right. Following your opinion, many TV news and entertainment programs ask interviewers to offer their opinion on the issue of the moment by calling an 800 number or a 900 number and voting on the internet. For instance, Nightline does this, and of the 186,000 callers one night, 67% wanted the UN out of the United States. At the same time, a scientific poll using a random sample of 500 respondents estimated the percentage wanting the UN out of the U.S. to be about 28%. The random sample is much smaller. Do you think it is more trustworthy or less trustworthy? Less? More? More? Why more? Why less?
You have to be someone's opinion if you go ahead and call in.
Yeah.
You're already,
Yeah.
you're already buying the information.
Yeah.
You're gonna want to call. If you didn't care, you
Uh-huh.
didn't call at all.
And also, it's limited to
People that want that.
the people that watch Nightline, yeah. So, the random one is actually more trustworthy, even though it has like a small fraction of the numbers. It's not so much numbers as is it really a random representation of your entire population that really matters. More so. Oh. Is the call-in poll a random sample? No. What type is it? Yeah, and there's one type of sampling that we talked about that is, well, no, type of sampling, that's a type of bias. I'm sorry? The convenience sample, exactly, yes. Yeah, and a volunteer sample probably as well, but a volunteer is a convenience sample, so. The job market for MBA students. Here we have a student polling 1,500 executive recruiters, asking their opinions on the industries most likely to hire. He received fact questionnaires from 97 recruiters, of whom 54 indicated that healthcare was the industry most likely to see job growth. What type of population, or what is the population for this survey? Yeah, the recruiters. University graduates. Yeah, I guess recruiters, like all recruiters, but not necessarily executive recruiters, but any person who's hiring for a job, and that would, I guess, best be called recruiters. Okay. What was the intended sample size? Yeah, the number, so it's looking for a number. How many did he intend to have? Yeah, 1,500, because he asked 1,500. What was the actual sample size? 97. And so what percent non-response? And again, non-response is the number who didn't respond. How many didn't respond? Or the frequency, relative frequency. 6.5 is the percent who did respond, but that means 93.5. Or in other words, 1,403 did not respond out of 1,500, and corresponds to 100%. That will give you 93.5%. Any questions on that? So 93.5% sounds like really high non-response rate.
But they're only going to respond if they have something, like expected.
If they have an opinion about it, yeah. Yeah, if it's the industry that isn't hiring, they're probably not going to want to say, oh, let me tell them all about how I'm not hiring. Describe 2 potential sources of bias with the survey. So again, we've got our out of the 3 types of bias. Yeah, definitely non-response.
Maybe response, maybe there's time, maybe there's
Yeah, maybe response, and really I think that maybe sampling too, because, and again, it might be that I just don't know what an executive recruiter is. Maybe it does include all recruiters that would hire MBA students, but I tend to think that that might be a headhunter or,
Isn't that what you would consider a headhunter?
Yeah.
Who's hired to
Yeah.
find a job?
so if it is a headhunter, then that's not everybody hiring. So he's already pulling from people who aren't a complete representation of the entire population. So, again, you know, so really it might cover all 3, depending on what an executive recruiter is. Teens buying alcohol over the internet. We had, in August of 2006, a trade group for liquor retailers put out a press release with the headline, "Millions of kids buy internet alcohol, landmark study reveals." Further details revealed that this study was surveying 1,001 teenagers, 2.1% of whom reported that they had bought alcohol online.
That's just the whole problem.
They'll ship alcohol as long as you don't live in a state that has a dry county, which Tennessee does.
So they wouldn't ship here.
Right. But, you know, my friend in Napa Valley, she's like, I want to send you some wine, but you live in Tennessee. So, but yeah, you can order wine or maybe even from liquor stores that are mail order. But you can definitely order wine from vineyards. Yeah. But they won't ship to states that have any dry counties. It's illegal to ship to states that have any.
Yeah,
That is
like
like-
Dry County, it is the most boring state to do without alcohol. And you live in your life over some beer or something, so
I went to school in Cookeville, which was a quasi-dry county, not completely dry, and really when I started school, they were almost completely dry. You could buy beer and wine coolers, but I didn't like beer and I didn't like wine coolers, so you had to go to the next county to get anything at college.
That's just, I mean, if you would have said that, like, as a gift to somebody, I would have never thought to order anything like that. But I was just, like, in awe when you read it.
Yeah. So you would need to have a credit card, I would think, or maybe PayPal.
And most people get a prepaid.
Yeah. So are all teenagers equally likely to respond to the survey? So it's going to have sampling bias because not all.
They're not gonna wanna get in trouble either.
Well, first, they're not going to be on the website that this was on, right? I mean, not all of them. Not all of them are even going to be online. So, well, the answer to this question is no. Yes, to sampling bias. Sorry.
Wow.
Non-response bias. So do you think there are teenagers who are likely to not respond to the online survey? Yeah, definitely. Either because their parents are maybe monitoring all of their internet activity or,
they don't want to stop the booze from coming.
Yeah. So response bias, do you think some people might have responded untruthfully? So, yes. So all 3 types of bias in this study. And again, just an example of how bias can enter into studies like these.